Hi everyone, this video is on the mixed exercise 9 question 20. We have a curve with the parametric equation x is equal to 2t plus 3 and y is t cubed minus 4t. The point A has parameter t is equal to minus 1. This basically means that if you want to find the coordinates of point A, you just need to substitute minus 1 into the equations of x and y to get the x and y coordinates. And the line L is the tangent to C at A. The line L also cuts the curve at B. So basically the tangent, which is L, cuts the curve at points A and B. So in part A, we want to show that an equation for L, or the tangent line, is 2y plus x is equal to 7. Okay, so in order to find the equation of the tangent line, we need to have the gradient of the tangent line and also the point at which the tangent line passes through. So in this case, that point is obviously A because the tangent line to C, it passes through the point A. So we want to find the coordinates of point A. And that's actually very easy because, again, from the question, they have told us that the point A has parameter t is equal to minus 1. So we just need to substitute minus 1 into x and y to find the coordinates of A. Okay, so let's do that here. We want to substitute when t is equal to minus 1. Then x is equal to minus 2 plus 3, which is 1. Y is equal to minus 1 cubed, which is minus 1, and then minus 1 times minus 4, which is 4, and that's 3. So the coordinates of A is basically 1 and 3. So this is the coordinates of A. Now that we have the coordinates of A, we want to find a gradient of the tangent line, and after that we can find the equation of the tangent line. So in order to find the gradient of the tangent line, we need to find dy by dx first. And this is a parametric equation. So in order to differentiate that, we are going to use this relation that dy by dx is equal to dy by dt over dx by dt. Okay, so let's now find each of these separately because we need to find dy by dt and dx by dt and then divide them to get the derivative. So dy by dt is equal to, because y is equal to it's t cubed minus 4t, so dy by dt is simply 3t squared minus 4, and then dx by dt is simply just 2. That's it, because 2t differentiates to 2. So this is dy by dx, but in order to find the tangent, we need to substitute the value of t is equal to minus 1. Remember that at the point A, t is equal to minus 1. So in order to find the gradient of the tangent, which passes through the point A, we substitute t is equal to minus 1 here. So when t is equal to minus 1, dy by dx is equal to, so minus 1 squared is just 1. 3 minus 4 divided by 2, which is minus a half. So this is the gradient of the tangent at A. So the gradient of the tangent at A. All right, now we have the gradient, we have the coordinates of A. We just need to find the equation of the straight line. So we can use the relation by the formula of y minus y0 is equal to m times x minus x0. So y0 is equal to 3. The gradient is minus a half, and then x0 is 1. Okay, so we can now expand the right hand side and rearrange this equation. Y minus 3 is equal to minus a half x plus a half. So just note that the form that they want us for the equation of the straight line is 2y plus x is equal to 7. So we need to multiply everything by 2 because the form doesn't have any fractions, and in order to get rid of the fraction, we can double the entire thing. So it's going to be 2y minus 6 is equal to minus x plus 1. Now we can rearrange this. So I'm going to add x to both sides. 2y plus x is equal to, and then add 6 to both sides, which is going to be 7. And this is exactly the form that we were aiming to get. 2y plus x is equal to 7. Okay, so this is the equation of line L, or the tangent line, and that's the answer to part A. Now part B is the interesting part of the question, because it says find the value of t at B. And just to remind you, the tangent line cuts the curve at points A and B, and basically this question is about finding the value of t at point B. So this is kind of the opposite thing to the previous part, because in previous parts we had the value of t and we found the coordinates of A, but this time we don't even have the coordinates of B to begin with. But this is kind of the opposite, but not exactly. Yeah, this time we want to find the value of t at point B. So for this part, we need to use a very wise trick in order to tackle this problem. We need to start with the equation of the tangent. So remember that the goal here is finding the value of t. So that means we need to have everything in terms of t in order to find the value of t. That's kind of you can use it as a hint in questions like this, because the unknown is another parameter. So if you keep going with x and y, probably it may not be the best way. So yeah, you can now think of, okay, how can you change things such that your final value of t is going to be in terms of t, obviously. That's one perspective here to have, but let me explain what's going on geometrically. Because we have the curve C, and the tangent line basically cuts the curve at two different points, so point A and point B. Now, in order to find the coordinates of point B, or at least finding the value of t so that it can help us to find the coordinates of B, what we need to do is basically substituting the values of, because we know, right? We know what is x and we know what is y. So we just need to substitute x and y into the equation of the tangent line. And by doing this, we have everything. We have an equation in terms of t, right? And that's exactly what we want. Because remember that at the tangent line cuts the curve. And this is a key principle that you have had this since last year, I mean year 12, which basically says that when two curves cut each other, or a line cuts a curve, at the specific point, the point of intersection, if you set the equations equal to each other, then you can find the coordinates of that. So here uses the same principle, but since it's parametric, it's slightly different to the usual types of questions that you just set the equations equal to each other. In this case, it's the same principle. The straight line cuts the curve, but instead of setting them equal to each other, we just need to substitute the equations of the parametric into the equation of the tangent line, and have everything in terms of t. So as a result of that, we are now going to substitute y is equal to t cubed minus 4t, and then x is equal to 2t plus 3 into the equation of the tangent. So we have 2 times t cubed minus 4t plus 2t plus 3 is equal to 7. Now we can expand the brackets. 2t cubed minus 8t plus 2t plus 3 is equal to 7. Let's simplify this. 2t cubed minus 6t is equal to basically, or actually I can take away 7 from both sides, so I have minus 4 here is equal to 0. And we can simplify this. We can divide everything by 2. So we are going to have t cubed minus 3t minus 2 is equal to 0. Okay, this is now the equation, and it's a cubic And normally, you know, in questions like this, we get a quadratic, but this time we have a cubic. But it's fine. It just means that maybe solving this might be a slightly more involved. Okay, now that we have a cubic equation, we obviously want to find the values of t and solve this equation, because the values of t here are going to be, one of them will be obviously -1, because these are the values that the tangent line cuts the curve, and we know that point A, which has the t value of -1, that's one of them, and we want also the one that for point B, which we don't know yet. So in order to solve this cubic, I want to remind you the technique that you have seen this before probably, and that's whenever you have at least one root or one solution to the cubic equation, you can then divide this equation by that factor in order to find the other solution. So let me show you. Because we know that one of the solutions is t is equal to -1, right? That's just from the question, by the way, they have given us. So we can even, you know, try that if you want to see if the solution, because -1 cubed is -1, then -1 times -3 is +3, and then -2, and that's 0. So this is one of the solutions, and they have given us. And it's not the case all the time, because sometimes you don't have any solutions, and the best way is just guessing the first solution, because normally at least one of the solutions is a nice number that you can guess. So between, probably you can go from -2, -3 to +2, +3. It's usually in that range. So yeah, if you're not given the solution, just guess that, just do trial and error. But once you get the first solution, then the rest of the question is easy, just algebra. Because to find the next solutions, you can always do that function that you have divided by that equation that you have divided by that solution. So in this case, it's always, remember, when you want to divide them, it's going to be that variable, in this case is t, minus the solution, right? So the solution is -1, but -1 is +1. So, you know, it's how, you know, when you have a bracket, it's like t plus 1 is equal to 0, and when you solve that, you get t is equal to -1. So that's the reason that we kind of reverse the sign here when it's t minus 1. It's just like rearranging and just having t plus 1 is equal to 0. So that's why we divide by t plus 1. And after that, it's just algebraic division now. So we start with the first term, which is t cubed. So we need to have t squared here. It's going to be t cubed plus t squared, and we take away from the bottom, and then t cubed minus t cubed is 0. So we don't have a t squared term on top, so it's just going to be minus t squared, and then minus 3t, and then we don't have a t term, so it's going to be minus 3t, and then minus 2t. Then for the next step, we want to make t to t squared, so it's just going to be minus t, minus t squared, then minus t times 1 is minus t. Again, we take away, so it's going to be 0 here. Then we don't need to write down the 0, but minus t squared plus t squared is 0. Minus 3t plus t is minus 2t, and then minus 2t here. And here we just need basically we just need minus 2 to get minus 2t, minus 2, and then taking away gives us 0. Okay, so we have basically factorized. This method is just, the purpose here is just to be able to factorize this cubic. Of course, if you want to factorize in different way, you can always do. But I prefer this method because I think that's the quickest. So this means that we can rewrite t cubed minus 3t minus 2 as the product of t plus 1 times t squared minus t minus 2. Now, the whole point here is that when we factorize to this, to a quadratic and a linear term, then solving these two separately is obviously very simple. And this allows us to find the values of t. So now, in order to solve this equation, there are two cases, right? Either t plus 1 is equal to 0, or t squared minus t minus 2 is equal to 0. But we know that this one, we already knew this one. So one of the solutions is -1. That's fine. And the other one is the second equation, in order to solve that, we can factorize this as well. So we can have t minus 2 times t plus 1 is equal to 0. And the solutions here are going to be t is equal to 2 or t is equal to minus 1. As you can see, minus 1 is repeated, but that's fine. It's possible in questions like this. So now what's happening is that, just to summarize, so we got the solutions minus 1 and also 2, positive 2. And remember that minus 1 corresponds to point A, and 2, t is equal to 2, corresponds to point B. So getting back what the question was initially asking was that find the value of t at B. So the value of t at B is 2. And if you substitute 2 into the equations of x and y, then you can find the coordinates of B, but that's not the point here. Yeah. So that's it for this video. And thank you for watching.